Hello students, welcome back to mathematics class. This is session number 2. Okay, let us learn more about circle in the new chapter, that is chapter number 4, circles. Okay, so now what do you mean by a circle? So before, if you learn circle, what do you mean by a circle? Circle means what? Set of points. Okay, so it's a set of points lying on a plane which is equidistant from the center. So center to your point, any point you take, their distance is same. Okay, it's a shape made up of so many points arranged on a plane which is equidistant from the center. Is called a circle. Okay children, so if I join all these points, it forms a circle as you learned in the last class. Okay, so now this is the center. Then center to any point, if I join, what we call that? That is called as radius. Okay, so radius. Radius means what? The distance between center to any point on the circle is called as radius. How many radius we can draw to a circle? Only one, children? No. So infinite number of radius can be drawn. Okay, so infinite number of, so all radius, how many radius if you join? They are all equidistant and they are equal length. So this is 3 centimeter means this is also 3. This is also how many radius you will draw? All are having the same length. So radius are equal in circle. Okay children. So how many radius can be drawn? Infinite number of radius we can draw. Not only radius. If I say about diameter. So what is the diameter? The line which is passing through the center. Okay, so the line which is passing through the center, which makes the circle into exact 2 halves, semicircles. Okay, exact semicircles. They are called semicircles. Why? Because this line passing through the center. Okay, so then this OAB. So here OA is the radius, OB is the radius. That means twice the radius. Radius plus radius is twice the radius, is called as a diameter. Okay children, how many diameters can be drawn to a circle? So there are infinite number of diameters can be drawn, which is passing through the center. Yes, no, not only this, so many diameters or infinite number of diameters we can draw. So these are all diameters. So it is called as the biggest chord. Diameter is called as the longest chord. Longest chord is called as diameter. So even if I go to the chord, if it is not passing through the diameter, that's a chord. Okay, so this is a chord. It intersects the circle at 2 points. Okay children, so this is called as chord. So now, how many chords can be drawn? Infinite number of chords can be drawn. So then, this is about the chord. Now, what we call this? When you join this part is called as arc. What we call this part? This is called as arc. Okay. So chord and arc between this place is there. No, that is called as segment. What do you call that? Segment. Tutu. Okay. So segment is this. Segment. The portion between the arc and the chord is called a segment. It's a small segment, you know. So it is called as minor segment. Minor segment. Okay. Then this portion is there, children. So this is called as a major segment. What do you call this? Major segment. Major segment. Okay, children. So chord and bigger arc joint means this part is called as my major segment. This part is called as minor segment. If I cut the apple from the side, one side. So this is this part, white portion and the pink portion of that apple. How it looks, that is called as chord. Okay children. So then chord next comes up is all you learned in your smaller classes. Okay. So now after learning this, let us see about tangents. Okay. So 3 figures I will draw on the board. You have to draw it in a math classroom. Okay, children. So the first one, circle and one line. Okay. Second figure, circle with this line. Okay. Third figure, circle and this. Okay. So the line, one circle and one line, in the 3 position how it is there, you have to understand. Okay, children. So now see here. First, here is the circle, center O. This is the line PQ. Okay, is it touching that circle? No, little far away from that, right? So this is called non-intersecting line. So it is no relation with the circle. So it is little bit far away from the circle. So this line is called as non-intersecting line. Okay, so non-intersecting line with respect to circle. So second case, this is figure number 1. Then figure number 2 says what? See, figure number 2 here. For the circle, this line, okay, intersect the line at 2 points. So this is at the point P and Q. This is AB. Okay, so now AB line cut the circle at 2 points. Intersect the circle at 2 points. Such lines are called as what line? As I explained in the earlier class. What is that, children? Yes, you are right. That is called as secant. What we call that? Secant. Okay, so intersecting the circle, the line which intersects the circle at 2 points. That is called as secant. Okay, children. So this is called as chord. Just cut at these 2 points. This is called as chord. If I extend this line, this is called as secant. Okay, children. So a line intersects the circle at 2 points. This is called secant. Now, third figure if I take with respect to the center, this line. So here, this line touches the circle. PQ touches the circle at only 1 point. Touches the circle at only 1 point. Then it is called as tangent. Already constructed in your previous lesson, right, children? So this is called as tangent. Tangent touches the circle at only 1 point or intersect the circle at only 1 point. Then it is called as tangent with respect to the circle. Is it okay, children? So like this, 3 figures are there. So how many tangents can be drawn or how many secant can be drawn to a circle? Infinite number of tangents can be drawn. But it should touch the circle at only 1 point. Okay, so if I say here, this is a circle, you can draw like this way. But it should touch the circle at only 1 point. Okay, if I draw another tangent here, it is parallel to each other. Okay, children. So parallel tangent, see like this you can draw. Parallel means. So it touches the circle at only 1 point. That is called as tangent. So how many tangents can be drawn? So anyway, like this also you can draw. So this is also a tangent, just a circle at only 1 point. Even this is a tangent. Okay, so if any figure given, you have to identify the tangent in that means it should touch the circle at only 1 point. Otherwise, it will become a secant like this. Is it okay? Secant intersect the circle at 2 points. Is it okay, children? Intersect the circle at 2 points. Now see here, about after learning this, we have to write about secant and the tangent. Okay, so what is the explanation of these 3 figures? Write in your math classroom. Okay, so the first figure says that, figure number 1 says that it's a non-intersecting line with respect to circle. So this is non-intersecting line. Non-intersecting line. Intersecting line with respect to. With respect to means WRT. The short form of with respect to. With respect to a circle. With respect to circle. Okay, so then this is figure number 1. Okay, non-intersecting line because it is not touches the circle or intersect the circle at any point. a line intersect the circle. A line intersect the circle in two distinct points. This line is called a secant. Distinct point. This line is called a secant. Okay. So if I come to the third figure, what is that? We have right here a line which intersect the circle exactly at one point. Touches the circle exactly at one point. If I take here R. Okay, children. So exactly at one point is called a tangent. It's called a tangent. Okay, children. In tangent, this point R, can you see here, touches the circle at only one point. Here a point R. Point R is called a point of contact. Okay, so point of contact. So R is called here point of contact. What is the meaning of point of contact? At that point only, circle touches the tangent. Is it okay? So you have to write about point of contact. Okay, these all questions will come in. Fill in the blanks. You have to answer these questions. So better write in your maths classroom. So write the point of contact. Point of contact. What is point of contact? Okay, so write the common point of the tangent. The common point of the tangent. Tangent and circle is called a point of contact. Children, so the point of contact. So R is called a point of contact. PQ is a tangent to a circle. Is it okay? So now the first figure is non-intersecting line with respect to a circle. Second one is secant. Okay, how many secant can be drawn? We can draw infinite number of secant to a circle. Is it okay? So secant means what, children? The line intersect the circle in 2 points, 2 distinct points. Then it is called as secant. Then the third one is called as tangent. The line which intersects the circle exactly at one point is called as tangent. Tangent touches the circle at one point. That point is called as point of contact. Okay, after knowing this, we have to understand what next in this. Is it okay? So let us start that. So take it down in your maths classroom. Okay, so now the most important thing you have to understand in this circle is 2 theorems. Okay, 2 theorems says what? That is the base of all the exercise problems to answer. Okay, so now see here, if I take the circle here, the tangent touches the circle at only one point, as I said here. Okay, so this is the PQ is a line touches the circle at R, then O is the center of the circle. Okay, so what we call this line, if I draw, this is called as radius. Okay, so through the theorem you have to understand that radius drawn at the point of contact. Okay, so radius drawn, this is the radius means you have to prove. So that means tangent touches the circle at one point, joined with the radius, makes an angle of how much degree? 90 degrees. So that means radius is perpendicular to the tangent. Means we have to prove using theorem number 1. So very important theorems are these. Okay, so 2 theorems are there and surely coming to your public examination. So better learn it. Okay, children. So now let us start the theorem number 1. Okay. Now right here, what says theorem number 1? Okay, so write theorem. The tangent at any point, at any point of a circle is perpendicular to the radius, the point of contact. Okay, to the radius, to the point of contact. Through the point of contact. Okay, to the point of contact. Now see here, how to prove this theorem. The tangent at any point of a circle is perpendicular to the radius to the point of contact. What is the meaning of this sentence here? First, what I have to draw? First, I have to draw the circle. After that, I have to think what they said. Is it okay? Now see here, the tangent at any point of a circle. Means what I have to draw? I have to draw one circle. Draw the circle. Okay, children. So now for the one tangent I have to draw itself. You know already tangent how to draw. Tangent touches the circle at only one point. Okay, children. So you have to write. So very simple theorem. Very easily you can understand. Okay. So the tangent at any point of circle. So tangent touches the circle at one point. Right, children? So we can take it as here. We can take it as x and y as I given in the maths classroom textbook. Okay. So now here O is the center of the circle. OP is the radius which touches the circle tangent. Which touches the tangent makes an angle of how much degree? 90 degree. You have to prove. Okay, so this is the figure. Circle with center O. Okay, then xy is the tangent, which point of contact is P. That means you have to prove that OP line is perpendicular to xy. Means you have to prove. It is in 90 degree. Means you have to prove. Okay, children, let us do it now. So what can I write here? First we have to write what is given in the problem. See here, read once again. The tangent at any point of circle, is perpendicular to the radius through the point of contact. Perpendicular. This is 90 degree or is this 90 degree means I have to prove. So 90 degree means I have to prove, no children. So I cannot write here first only 90. Okay, now see here. Before learning this, I will explain you one thing. Always to understand, children. So, which is the line perpendicular? That is only the smallest, shortest distance. So, radius drawn to the point of contact is itself is the shortest distance. From all the distance, this line is the shortest. So, that line is only a perpendicular line. Actually, like that it is it okay? So, radius drawn at the point of contact is perpendicular. Why? Because this distance OP distance, whatever I took is the shortest distance, means I have to prove first. Shortest distance means I have to prove first. That shortest distance is itself a perpendicular. Okay children? So directly perpendicular means cannot prove. So that OP is the shortest distance means I have to prove first. After that you try that shortest distance itself is a perpendicular. Okay, how can I prove that? Just see here. Okay, so that first one is given. Given. What is given? O is the center of the circle. O is the center of the circle. Okay, O is the center of the circle. Then XY is the tangent drawn to a circle. So XY is a tangent to the circle point at the point B. XY is a tangent at point P. Point P. Okay. So then that tangent is perpendicular means I have to prove. To prove. What to prove? So what to prove? OP is perpendicular to XY means I have to prove. OP is perpendicular to XY means I have to prove. How to prove that? What can I do to prove this? It's a perpendicular means. So what can I do is take the construction. So extra finger to construction. Okay. What construction you want to do? See here. You have to join one more line. Okay. So like this. See. Take any point on the tangent. Okay. If I take here Q. Okay. Join this. OQ. So mark a point Q on XY and let it cut that OQ line at R. So this is R. So children, can you make up here? When I draw OQ line, it will cut that line at one circle point here. Yes, no? So that point you have to name it as R. Okay. So that means what you have to do? Mark a point Q on XY such that let it cut OQ at R. Okay children, so like that we have to write here. So this is the construction. Why means I will explain you now. So mark a point Q on XY. Mark a point Q on XY and let it cut OQ at R. OQ at R. Okay, so let it cut at R. Now here, then just see here, OQ is a line. I drawn, okay. So let it cut the circle at R. Okay. Now what happens? See here, after construction, you have to do the proof. Yes, no? So what is the proof? What is the proof? Just compare now. When I draw this line here, so who is bigger? OQ is bigger or OR is bigger, children? Yes, you are right. OQ is bigger than OR. Will you agree or not? So through the figure we can understand. See here, OQ is greater than whom? OR. Yes, children. OQ is greater than OR. But OR is also equal to whom? OR is this length is also equal to this length. Why? Because they are radius. How many radius you draw to a circle? All radius are having equal length. So see here, OR is radius means OP is also radius. No children. So now OR is equal to OP. Okay. So just compare. But with this. Okay, just see here. Therefore, OQ is greater than OR. OR is also equal to whom? OP or not? That means OQ is the greatest distance of than OP. OQ is the biggest, longest distance. So it's a lot greater than OP. than OQ is greater than OP means if I draw any number of lines to this, any number of, they are all greater than OP. OP is only the smallest in this. That is only the point of contact with the radius here. Is it okay? So this length is only smallest. Any length you draw other than this P, so they are all longest than this length. Is it okay? So this much only you have to prove. So therefore OQ is greater than OP. Okay? If you take any number of lines here if I take here P, OT is also greater than OP. If I take here U, OU is also greater than OP. That means which is the shortest length in all the lines, OP is only the shortest distance. So you have to write here, the main thing you have to write here, see here. Now since this happens for every point on the line xy except the point P. Okay, so OP is the shortest. OP is the shortest of all the distances. OP is the shortest of all the distances. Okay, of the point O to the point of xy. To the point of xy. So OP is the perpendicular. So therefore OP is a perpendicular to OP is xy. Means you have to write. Okay, so it is bit theoretical form. You have to write a very simple thing. Okay, which is what you write here. Since this happens for every point on the line xy. Since this happens for every point on the line, means all these lines, how many lines you are drawing on the tangent, they are all longer than this OP. So, except xy, except the point P. Okay, OP is the shortest of all the distances of the point O to the point of xy. The point of xy. So, OP is perpendicular to xy. Okay, so your main aim is to say that OP is the shortest distance. Means you have to prove us that shortest distance is itself a perpendicular. Means you have to write it. Okay, very simple. Actually, it's very simple, children. OP is the shortest distance of all the distances. That shortest distance itself is the perpendicular. Means you have to prove. Okay, that much is there in this theorem. So, hope you all understood. See again. So, right now, so everybody write down exercise number 4.1. Exercise number 4.1. Okay. Now, first question is this. How many tangents can a circle have? How many tangents? How many tangents? Tangents can a circle have? Can a circle have? How many tangents are there for a circle? So, if I take one circle, how many tangents can be drawn to that circle? I can draw in this way, or this way, or this way, or this way. So, how many tangents can be drawn? Infinitely many tangents can be drawn to a circle. Okay, children. So, question number 1. What's the answer of that? How many tangents can circle have? Circle have infinitely many tangents. So, you can write your answer infinitely many. infinitely many tangents. Okay, children. So then, thereafter, next question. That is fill in the blanks. Fill in the blanks. Fill in the blanks. Okay. So in that first one, a tangent to a circle intersecting dash points. Tangent intersect the circle in dash points. Yes, you are right. 1 point. Yes, children. So first question answer you are right. A tangent to a circle. A tangent to a circle intersect it in dash points. How many points? Tangent touches the circle at how many points? 1 point. Yes, children. So then, second question. A line intersecting a circle in 2 points. In 2 points is called dash. A line intersecting a circle at 2 points. A line intersects the circle at 2 points means what is the answer of this? This is called, which line is this? This is called as secant. Yes, children. So this is secant. Then third question. A circle can have dash parallel tangents. Dash parallel tangents at the most. A circle can have dash parallel tangents. Means a circle is there means at the most how many parallel tangents can be drawn? So that is 1. This is parallel tangent. Can be at the most how many? At the most we can draw 2 tangents. Okay, 2 parallel tangents we can draw. At the most as means 2 means you have to write. Okay, the last question. The common point of a tangent to a circle and the circle is called the common point of a tangent to a circle and the circle is called as, what is the meaning of this thing? This point is called as point of contact. Yes. So the answer is point of contact. Okay. This much about fill in the blanks. Some more problems are there. Let us continue that in the next class. Till then, take care.